Alrighty, we're going to learn about critical numbers and what a critical number is, how you find it, all that kind of fun stuff. So, by definition, a critical number is let's let f be defined at c if the derivative is equal to 0 or if we are not differentiable at a number, c, then c is a critical number. And I mentioned this earlier in the year, but you guys are familiar with setting an equation equal to 0. So if you have a polynomial, you just set the polynomial equal to 0 and solve. However, if you have a fraction equal to 0, that's going to happen basically when your numerator is equal to 0. So when the numerator is equal to 0, let's write numerator. Let's go. When the numerator is equal to 0 is when f prime of c equals 0. If the denominator is equal to 0, that is when f is not differentiable at a place. So we're going to use this actually pretty much from now until the rest of the unit finishes. But the biggest thing for right now is just us making sure we can find a critical number. Today's actually pretty basic in that sense. So if I want to find the critical number of just these two equations, first one's a polynomial, so the derivative is actually going to be fairly easy for us to find. It's going to be negative 3x squared minus 10x minus 3. I want to know when that is equal to 0. Basically, I'm finding when I have horizontal tangents. Those are going to be critical numbers to us. Everything is a negative in here, so if I actually multiply everything by -1, I'm going to end up with 3x squared plus 10x plus 3. That is a factorable equation. If you can't factor, you can always try the quadratic formula. This is factorable. 3x plus 1, x plus 3. The outside is 9x. The inside is 1x. That's what adds to 10x. And 1 times 3 is 3. So we use the zero product property to solve. And we get a critical number at -1/3. And we also get a critical number at -3. I really don't need you guys to know what they're used for today. I just need to make sure that you guys can find them. We'll use them for something tomorrow or Monday. So if you have a rational expression, it's me finding the derivative. This is actually one that I don't need the quotient rule for because I can just use a power rule. So I'm going to end up with 3 times x squared minus 4 to the -2nd times the inside derivative, which is 2x. So I get 6x over x squared minus 4. Quantity squared. So this fraction is going to be equal to 0 when the numerator is equal to 0, which happens at x equals 0. Now technically I have two places where I'm not going to exist as a derivative is not going to exist, but actually from the get-go, those two places are asymptotes. So they don't count as a critical number. They will be something we will use later on, but they're not going to be, I already don't even exist there. So actually something that we want to add to this, we have, well, emphasize on here, f be defined at c. So it's where you are defined and maybe not differentiable. This is not differentiable at plus or minus 2, but I wasn't even defined there to start. I am going to use those with what we're going to do with this later on. We are going to use plus and minus 2 in our work, but technically they're not called a critical number. They're just considered an asymptote. So all I need you guys to do today is to make sure that you can find where we have critical numbers. So essentially it's where you have horizontal tangents and if there's any place that the derivative does not exist. Have fun!